Well, hi, good morning, and thank you so much for joining me in my shop. Today is March 12th, and things have gone a little crazy for my meager YouTube channel since I posted a video a couple of days ago. The video was to my existing viewers, just telling them that I was having a bit of a struggle keeping my head on my shoulders because of the effect of the actions of the United States on that. A lot of changes have occurred in me. I think I'm having the same experience as pretty much every Canadian. Shock, dismay, anger, and now action. We're at the action point already where, you know, we need to do something. So, not to talk much about that, what am I going to do with all of you new subscribers? So you've subscribed watching a video where I was just talking about the situation here, and that's not what my channel is. My channel is fixing these old radios. This one here is soon to be on my bench. That one in the back there is the one I'm working on right now. And normally when I'm in here, I know I'm talking to people who have been following the video and know what I'm doing and are radio people and all that kind of stuff. Now there's thousands of more subscribers on my channel, and I don't know if they are in any way interested in these old radios. So I've done my best to keep my channel free from politics. That's not really what I want to be doing. That last video I was just expressing how I was feeling and really trying to explain why my videos have become a little bit choppy. I think they've become a little bit choppy. So here's what I think I'm going to do. I've got a number of ideas in my head of how to handle the situation with my YouTube channel. So here's an idea. For all my long-term viewers, I want to continue just making videos about old radios like this and not turn into a political channel. There are so many of them out there. There's no need for my voice to be included. But there is something I can do because I feel I should do something, and so I'm going to reserve the first couple minutes of my next videos talking a little bit about the situation before I just stop that and just get to work on a radio like this one. So today I'm going to go ahead and do that. I'm going to go ahead and spend just a couple minutes now talking about something that I think will be helpful to Americans and to Canadians here. So what I'm going to start with is the dramatic difference between the top of the American government and the top of the Canadian government. And I'm not talking about people, I'm talking about structure. So let me describe the American government. This is how I understand it, so maybe I got it wrong, but the Americans, one thing about them is they're very open and everything is out there for everybody in the world to see. So I think I got it right. So the Americans elect a national leader with a national election that all Americans participate in, and they select the top guy, their president. Well, they actually see it as one of three co-equal branches of government, so it's not really a top guy, but certainly different than the other branches in that. That individual then selects a team of people to assist him in the running of the government as described in the laws of the United States. And so he selects a cabinet, I don't know how many people, usually around a dozen or something like that. It's pretty typical of a cabinet. Can't be too big, can't be too small. And those people are selected just by him, people he knows, people he's heard about, people he believes are particularly skilled or appropriate for those positions, and then together they form a team that runs the American system. Sort of the president, kind of captain of the team. He's really in charge because he can hire and fire these other people who are only there because of his good graces, that he selected them to be on the cabinet. Now we look at the Canadian equivalent. It's not equivalent at all. It's not equivalent at all. It's completely different. First of all, we don't have a national leader. We have a person we call the Prime Minister, but they are not nationally elected. They've run in a small area. We call them ridings. The Americans call them districts. We call them ridings. Probably goes back to when people had to ride a horse, and it was basically how far you could ride a horse reasonably. that describe the area that a particular politician might be responsible for. Today we do it by population. We have representation by population. So we break the country up into pieces, roughly 150,000 people in a piece. We call that a riding, and somebody runs to be a politician in that riding. We don't have a national election. There is no election for Prime Minister. We do not elect the Prime Minister. The Prime Minister becomes Prime Minister because he happens to be the leader of the party that got the most seats. So think about that for a minute. Now, who does he pick for a cabinet? He's the Prime Minister. The Prime Minister, he gets to pick the cabinet. So who does he pick for the cabinet? He can pick anybody. He's free to pick anybody. He could do what the Americans do. He could pick a pile of private citizens and have them come in, but that's not what happens. In the Canadian system, what the Prime Minister does, inevitably, is he picks other politicians to sit in the cabinet, from his party, of course. And so the winning party ends up populating the cabinet with politicians, each of which has been elected by roughly the same number of people, a tiny portion of the overall population of Canada. Nobody has a national standing, including the Prime Minister. When the President sits down at the table with his guys, he owns those guys. When the Prime Minister sits down at the table, he can hire and fire them, but they remain politicians. And they all look at him and know that he's got just as much political authority within the Canadian election as they do. They're elected by the same number of people. He's not really that different as he sits at the head of that table. Not from that point of view. He's far, far, far from a king. So, those are the differences. The Canadian cabinet filled with politicians, no national leader in the country. They got to get along as a team, and I think that's how Canadians perceive it. We look up and we see a cabinet running the country. We hear about the Prime Minister and all that kind of stuff, yes, but we see a cabinet running the country. But you look at the American system, I don't think Americans believe the cabinet runs the country. Not right now. They believe one man runs their country. Yikes. Yikes. Okay, that's it for that. That's it for that. So I'll try and do these things where I believe there's something worth knowing. Some factual thing. I'm not going to offer my opinion. My opinions, we've all got an endless supply of opinions. Why should we care about each other's opinion? What we should care about is the facts upon which we are basing these opinions. That's what we should be talking about all the time. Okay. Now, that little ding was my cat stepping on my keyboard. Computer's still operating. Okay, let's get back to this radio. So it's been a few days now since I worked on this. And many of you are new to my channel and you probably haven't watched video 1, 2, 3, or 4. There's probably ultimately going to be about 10, 12 videos on this radio. I'm about halfway through or so. The radio appears to be largely working. And I've tested all the tubes. Tubes are okay, but one of them is weak. Can't remember which one's weak. What are you guys growling about? So, seldom here to be seen is my big senior cat. Where'd he go? We're just here. Oh, here she is. Shadow, come on out and show yourself, because my little cats get on here all the time. Come on. Come on out here. And there she goes. Yes, we have 3 cats here. Okay, back to the radio. Yeah, if you're not used to watching my videos, hang on tight. I turn the camera on and I shoot the video. I do almost no editing on these videos. So stuff happens here while I'm living my life with the camera running. You're going to see it. Okay, so I've tested the tube, so that's not an issue with the radio. The radio worked at one point and then didn't work at another point, and actually I don't even know yet. I don't know the state of it. At this point, I have to. Well, we'll plug this in and we'll make it operate right off the bat, mostly to remind you of the state of affairs with it. Work sometimes, work not other times. Don't know why. Not the tubes, probably parts underneath, which I haven't shown you yet. Again, I've got a complicated situation here with viewers who have watched all the videos. They don't need an update on this, and then piles of new viewers who are going to be clueless about what I'm up to here. So, string is gone. Here's a bit of it here. I'll have to put a string on at some point. I have 3 cats playing behind me. I put the power cord on. The original one was shot. There was a 3rd capacitor in here. Here it is here. It was in there in a place that I think it shouldn't have been. These are 2 replacement capacitors. They seem to be holding the fort fairly well. The radio's not humming very much. You can see all these old wax capacitors. That's not these, but these and these. That's probably where I'm going next. After we operate the radio and take account of its operation. I own this radio. Most of the radios you'll see in my shop I don't own. This one I do. I would never have bought this radio because when I went to get it, the lady I was buying it from said, "Oh, and the speaker's missing." That's true, the speaker was missing in this big radio. By the way, again, because you're new and you had not been watching, that's the radio I'm working on. That's what the cabinet looks like. You can see the dial in the front here. Just so you know, that's what's come out of it. And let me grab the speaker here. So with no speaker, ooh, that's a big problem with these old radios, because the speaker is not like a modern speaker. Modern speakers, you just send the sound signal to the speaker and it operates. Not so with these guys. This is old enough that making a powerful magnet was not something that was done. It's catching on. Oh, it's this nail catching on the rubber here. So, because they couldn't make magnets strong enough to do the job, they had to use an electromagnet. Well, in here is a big coil. That's a big electromagnet, and this forms part of the power supply of the radio. The point is, you can't swap these speakers back and forth between radios easily. But in my case, I could. I was very lucky. This is a General Electric. See, this is GEKM67. Somebody else wrote that. That's what this speaker's actually from. And this is a Philco. It has nothing to do with the General Electric. Yet they use the same plug and it's wired the same way. And I'm just so lucky. You can actually just plug it in and away she goes. So I really didn't think it was going to work out that way. Let me just... Don't really like that, but it'll do for now. So we've got to get the antenna arranged. So we have an antenna on it, and then we're just going to play it and see what it does, and then I'll think about what to do next. Okay, so my cat Bert is here visiting, and his brother's just behind me. 2 of these guys. Yeah, okay, so I need to connect an antenna. I've forgotten which wire is the ground and which one's the antenna, so we'll take a look at that. Okay, so the ground, colors are different underneath the chassis. Black one. Okay, no surprise in that. The lighter brownish one is actually a green wire, but the colors fade, of course, and can't be relied on. So I'm going to power this radio up in my shop here, and many of you are viewing this stuff for the first time, viewing me do this stuff for the first time. I have an isolation transformer that is preventing me from getting ground shocks. So the isolation transformer feeds power to this plug here, which is on my bench. This is what I plug all the projects into here. I also have this device here, which you can see, the big knob on it. I can turn the volume. We have volume too, actually. Voltage up and down over quite a range. So I can control what kind of voltage is coming to the radio, because you don't know what to expect at first, or different times while you're working on it, and maybe moments where you're a little concerned. But the real way I protect myself here while I'm working, and maybe not protect myself, but I guess to some degree, is to use a dim bulb system. That's these two light bulbs here. These are older incandescent filament type light bulbs, and I can pass the power through them on the way here. And what that does is, with the light bulbs in series with whatever it is you're working on, if there's a short circuit in the thing, then all that happens is the lights come on the way they would if you just plugged them into the wall, normally. And that, of course, in my case, because of where I have the lights, they blast me right in the face. I know right away something has happened. So normally, though, I often leave them in the circuit while I'm working on stuff. I just jack up the supply voltage to compensate for the loss on the bulbs and carry on. The bulbs are also give a good indication of the proper operation of the radio during startup, because of the way the bulbs glow changes as the radio starts up. So that's one of the things we'll observe right away here. We're ready to do this. So the objective here is turn on the radio and see what it does. I've done virtually no work on this radio to this point, other than testing some tubes and discovering I can plug the speaker in. So okay, that's the band switch. Okay, so this is the volume switch, volume control here. This is the tone control with the on-off switch. So we'll turn it on. We'll turn the volume 40% or so. And one last look. Very good. This is the antenna connection going to an outdoor mini whip type antenna. Here we go. So you see the dim bulb come on. Excuse me. Came on fairly bright at first, or brighter at first, because the tube heaters are cold and a lot of current will flow through them. When they heat up, the resistance goes up, the current goes down. The bulb gets dull. Now you see the bulb brightening up. You should start hearing something from the speaker. The bulb brightened up because the tubes themselves began to demand current. Once the radio gets operating and high voltage is present in it, current starts flowing in these tubes, and that's what's lighting this bulb. And that's a pretty heavy current. So right now the radio is operating with 97 volts, 79 volts, which is really low. So what I'm going to do is I'm going to flip the switch up. It's going to this switch here. This is going to redirect the power not through the light bulbs but straight to the project. So it's going to get full line voltage. Now it's running well. 108, a little low. Hard to see that. 108 volts, but it's operating, that's fine. Volume control. Now, is that really receiving something? It's receiving something from the antenna. Yeah, we'll now tune the radio and we'll see if it makes any difference. See, tuning the radio, there's no difference. It just oh. But not at all what you would expect in a working radio. So which band are we on? We should be on band number 1. So I want to make sure we're on the broadcast band. Yeah, broadcast band is the most counterclockwise band. So stuff is coming through the radio but not being tuned properly. If we go to the shortwave bands, first one, tiny influence on the radio from the antenna. That's not a good sign. And Nothing. All that scratchy, probably dirt in here. Scratchy sounds. So there is a set of push buttons, and for this radio to operate with the tuner like this, you need to have this button pushed in. Let's check and make sure that button has really made proper contact. Maybe it hasn't. Where are we now? Are we back on the broadcast band? I don't think so. Back on the broadcast band. Well, I don't think that's the problem. Oh, I gotta take that back.
He continues. This is supposed to support some important milestones, including.
Well, you see how these this thing acts like a tray catching dirt right on top of the switch, and the actual switch pieces are right in here. Let's take a close look at that. Oh, that was my hand touching the tuning capacitor there. So I'll work the switch here. Look at the amount of dirt on it. That's unbelievable.
Said they were proud to be Canadian. Karen Rebo, the Canadian Press. Investors are buying the dip on the stock markets with a bounce for the tech sector. Business with Mike Ethel in 60 seconds. City News Time 9:25. News to buy new plans so people can unlock the equity in their home. Unique like this one. It's called the Aaron and Catherine plan. Aaron was in the middle of selling his small business and wanted to pay off some debt. Truth is...
Well, okay, so there's a good example of how lucky a person can be. That was a high portion of luck with a tiny amount of skill associated. So typically in these old radios, the switches are dirty and stuff happens, so I'm not surprised. So I'm going to work at cleaning these up, all of them up, and hopefully we'll get rid of this. But it's really, I better turn the power on. It's really a lucky break that this just happened. Wow. I'm going to go drink some coffee too. So to clean this, I've sprayed a couple different kinds of cleaners, including one that's really meant for your car, and then I just brushed it with this. But this is a plastic bristled brush, so I've gone out and got a, this is not plastic bristled. And what I'm going to do is I'm going to just slap some alcohol on it here. Lots and lots of alcohol. So this is already pretty clean. I'm kind of doing the finish part. I like alcohol because it will totally evaporate. And I think this brush will absorb some of the grease and oil that's in there. I put way too much on. That's okay. If you look at the front panel here, you see all the staining that has occurred on it. Some of this could be from oiling these things previously. Somebody previous could have done it, or maybe originally even. There may have been a touch of oil that's managed to get up into this backing. So we have to let this dry before I turn it back on. But in fact, I think it's going to work fine now. But I think I should let the let this evaporate, or we're going to have a fire on here. Good, that's kind of lubricated the switches too. Okay, let's clean them up here. Wow, these are really, really dirty. There's really a buildup on them. I guess, you know, they're protruding from the front of the radio, so they're collecting the dirt that's falling down onto them. Okay, let's put the top on this before I have an accident. One of the cleaners I used, which I would never recommend, So this is really meant, look, it's meant for your car, you know, doing car stuff. But this is a very powerful, volatile solvent. That's what I started with. Okay, so this is still needs time. Hey, time for some more coffee. Okay, let's give the radio another try here, and this time we might get something on shortwave. Here we go. Okay, so I've got the broadcast button turned. Patience. We must have patience. Here we go. That was interesting. Initially, you couldn't hear the radio station, and then it kind of came in. I think the oscillator started working in the radio.
Time 10:01.
Time for Rogers Xfinity Internet traffic and weather together on the ones. Where are we looking, Greg here?
Here to the doctors who are working through it, and of course, are the Fahad, who is the last scientific advisor.
All these stations, by the way, that I hear during the day are within a couple hundred miles of here. Almost all Canadian.
Really, the most difficult.
We want to put serious consideration.
Répond que les voisins du Maine sont nos amis et qu'il faut être très prudent avant.
It's American. Nope, not American.
He is backing down on his 25% tariffs on electricity.
Oh my God, people use the word tariff all over the place now, and they should not. The real words, not tariff. Tariff has been destroyed. So the real words are import tax and export tax, and we should use those terms and stop saying tariff.
Doug Ford initially said he wouldn't budge, even as Donald Trump vowed to double incoming steel and aluminum tariffs to 50%. The change of heart after a call from U.S. Commerce Secretary Howard Lutnick.
There's a point that both parties are heated and the temperature needs to come down.
Ford and federal finance.
What do you think? 80 to 26. Depends on weather, depends on traffic, but I will finally land back in Toronto and
Might get a station up here. No. So here they like shoo 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 sound. So I believe the radio is picking up carriers from distant stations, but not nearly enough to produce audio for us to hear. But each time a carrier goes, each time I tune across a carrier, you hear that swooshy sound. I believe that's what's happening. And that's probably from bad parts underneath. Hey, let's check out the shortwave band. Okay, so first band is the band that goes all the way from like 6 all the way up to 15 or above 15, I think. So there we are. Are we working here? Doesn't seem right.
for it, people. Well, she went off to her work. A few minutes later, she heard this cat that was screaming in the kitchen.
This is probably 9.33 megahertz we're listening to.
And she said, "What are you doing, son?"
Well, that's all we need. It works. Let's go to the next band. Probably all these bands, they're probably going to work. I don't know if we're going to pick anything up. This would be, I think, let me look at their radio here. What is this? This is 9 megahertz band, 31 meter band, I believe. So we should hear some stuff on here. Well, we might, rather. You can tune fairly fast here. Is there spread band? Nothing at all. Do you think that's working? I'm not sure. Okay, we'll go to the next band. This one would be 11 megahertz, 25 meter band. Well, unless the sun is, some blast from the sun has blacked out our... Okay, next band. It's music. Okay, what I would say about that is the radio has all the potential to work, but there are things wrong with it that are making it not work. That's a pretty good conclusion there. Yes, sirree. Because the broadcast band is coming through loud and clear, that sort of proves that the bulk of the radio is operating as it should. The failure to pick up shortwave, it's a combination of there may not be any shortwave there to pick up. That's not very likely. Probably should have picked up 5 or 6 stations there that we could have listened to, but we only heard the one. The one that we heard is very, very strong compared to the rest. So I think the situation is on shortwave. It's weak because of bad alignment. We also heard the oscillator start late as the radio warmed up, which may indicate that the local oscillator is weak. And the lower frequencies, it's usually they're weaker on the lower frequencies and stronger on the higher. Although I would think it'd be the other way around, that you'd have trouble with the oscillator at the higher frequencies. Maybe that's part of the picture here. Otherwise, not bad for a radio that's full of old parts. I'll show you those old parts now. Let's take a look at them. Full of old parts and an awful lot of dead spiders I noticed up in here. So once again, all these capacitors here are potentially not doing their job, and that could lead to that swooshy sound we heard maybe, or other stuff, and also the general weakness. It's possible the capacitor under here is causing that. It's more likely an alignment issue, but who's to say? So I think the next step to try to maintain the fun as much as possible is to try to figure out which one of these capacitors, or which ones of these capacitors, could be responsible for the poor radio performance that we're seeing now. And it's almost certainly up in this area. I got a wax one here, here, and if it is a capacitor, it's probably one of those. But we have to study the schematic a little bit now. I'm trying to get some work done here. Look at the situation. Hard not to love these cats. I was quite angry with him this morning because he kept jumping up on the kitchen counter. They haven't learned yet about the kitchen counter. Every time I turned around, he jumped up on the kitchen counter. You bad guy. Okay, so I'm allowing those of you who love cats to get your cat fill here. There we go. Okay. Let's take a look at the schematic. I think I had. Do I have it here? Let me see. Here it is. Okay. What capacitor on here might be the one that's highly responsible for the weird swooshy sounds? And my guess is it's the capacitor whose job is to hold the screen voltage fixed. So we look for screen tubes. There's one here, and there's a couple here, and the screens are tied together and powered by this circuit here. And there's a capacitor there whose job it is to calm this down. Try to hold this voltage as steady as possible while the tube's operating. So this capacitor, number 27, would be a potential bad actor for this swooshy sound. Now, are there some others? And you know, I'm not 100% sure of this. So here's another one. This one would commonly be called the ABC capacitor, and it is right on the grid circuits of these tubes, right on this one too. So its real purpose is to buffer the action of or slow variations in the AVC voltage. I'm sure it has other jobs too. So maybe this one is also involved in quieting down feedback or swooshy stuff we're hearing. Maybe. Now, is there another one that could be implicated in this? And again, what do I know? This is how I find out about the truth of these things. Now, see this dotted line here? That's a can. Inside that can is this capacitor. Now, it's 100 picofarads, so I probably shouldn't worry about it. But this capacitor is actually inside a can. So is this one. Let's see. This guy's carrying the audio. He's not going to be responsible for the swooshiness. This is all audio down here, and the swooshiness is coming out of the radio, I'm pretty sure. I think really it's only those two that could hold some responsibility. This guy here is a bypass going around this cathode resistor. I think if this is not working well, what you end up with is too much of the supply signal dropping across this resistor, and you'll lose output, you'll lose strength. This is part of the local oscillator. The oscillator is this circuit down in here. The oscillator came on late and appeared to fail to work earlier, but that was probably because of the push button that was actually causing that. So, you know, maybe this is out of sorts. Maybe this resistor's gone way high and the bias here is wrong. And maybe there's some more going on here. But for now, we're after the swooshy sounds. I think we should do this guy first. Number 27. And this would be a tough one to find. It's hooked up to a 22K resistor and hooked up right onto the screen. So I should be able to look at the screen terminals of these tubes and trace back to find this capacitor. Very good. Okay, if we pick the 78, the tube number 78, that's this tube right here. 78, the screen is on grid, or on pin number 3. Screen on pin number 3. Okay, now how do you count these pins? This is a pre-octal tube. I think you count them with this number 1. For God's sakes, I forgot the number already. All I gotta do is just say one other number, and it's like I got a shift register in my head and stuff keeps falling out the far end of it. 78. I have a very small shift register. Okay, 3. So one more time. 3 is the one we have after. So we go 1, 2, 3. So it could be this. So if it's this, oh my gosh, what all's up to it? There's all kinds of stuff on here. Oh no, there's a wire going. Oh, look at this. Wire going to another pin direct. That looks like screen connected to screen. Now here's a capacitor, and it's going to a grounded terminal. That's for sure a grounded terminal there. The way I can tell is it's tied along this line. Can you see? You probably can't see it, but there's a wire, a bare wire running all the way along here. Bare wires are usually at chassis potential. They don't bother spending money on the insulation for the wire. Put a bare one in. You can see here's a rivet to ground and the ground like so. Definitely. So this is the guy. This is the guy here. Okay. Well, we're going to change this one and see if it has any effect on it. What is it? 0.05. And we're also going to test it. We will test it and see. Clip lead. Please. So the clip lead is to help me remember where the capacitors come from, because I never know when I'm going to be distracted. There we are. Here it is. 0.05 is it? 200 volts. 0.05 there, it says right there. Okay, so we're going to test this on my vintage capacitor checker here. Oops. Nothing awkward about this. Okay, here we go. So what this guy does is it puts a high voltage, I select the voltage here, across the capacitor. A brand new capacitor, you can put the maximum voltage here, 450 volts across a brand new capacitor, and there'll be no current, no detectable leak of current in here. The way the current is detected and shown to us is using this magic eye. What's happening here? I'm stepping on the camera cord. So you look at the magic eye, you see it's open at the bottom right now. And my unstable arrangement here is drifting. See if I can stabilize things a little bit. So when if I were to put a short circuit on these leads here, then and turn this on, the eye would snap shut and stay shut. So any current flow makes the eye close. When I hit the switch here, the capacitor will charge, a current will flow, the eye will close, but it will pop open again if the capacitor is good. If it's a brand new one, I could do this at 450 volts and this thing would be open like this. This is certainly not a new one. Be lucky if even 50 volts. That's where it's set right now, 50 volts. Here we go. So you see the eye pop open, like just it flash closed for just a brief instant. That's not supposed to happen with a capacitor like this. So I think maybe I didn't make connection here. Let's try it again. So it's indicating to me that there's a defect in this capacitor, and it's actually got no capacitance. I think the lead is separated inside. So it's not just weak or leaky, it's just not there. We're going to test it on another device now. That's if I can. Oh, I've locked all this up. You know, okay, I'm not the best cameraman. That's really not what I'm trying to do here. We'll test this on another device. Now, all these capacitor checkers that I have anyway, if the capacitor is leaky, the test results are wonky, or invalid, I guess would be the right word for it. So often a capacitor will show itself to be bigger than its rating because of a leak when tested with testers, including this one. Let's see what this one says. So 38 nanofarads, and the test on the other tester, if I put a 38 nanofarad, wait a minute, 38 nanofarads, I'm thinking picofarads. That's 0.03 or 0.04. That's close. That's close to being correct. Wait a minute. Well, maybe this reading is elevated because the capacitor is leaky. It's got to be leaky. This is a bit of an anomaly here. I'm going to get a brand new 0.05 and we'll compare its behavior in the other tester. A brand new 0.05. Brand spanking new. So what I'm doing now is I'm testing the tester and testing myself, in fact. Have I become a crackpot? What has happened here? I'm getting this conflicting reading. So this also keeps me honest when I do stuff like this. So what's the response? Now I'm thinking this is not going to snap closed. It's going to close and then open quickly. It's going to be quick. Here we go. Well, it's just like the other one. Okay, we'll put this up to 350 volts. You can see the charge coming out of it by the behavior of the eye when I let go of the test. So, and just to prove, 450 volts. Look at that. Now you can see it. The charge was greater, took longer to discharge. Hey, let's try that with the other one. Can we see the discharge? Careful now, there could be quite a charge on that little capacitor there, Jim. So this device, when you let go of this switch, which is spring-loaded, it goes to a position which puts a short across the test capacitor to discharge the charge. Okay, once again, not 450 though. Starting at 50, what do we get? Now it's starting to test like new. Let's go up to 150. This is a 200 volt capacitor, so we're really not supposed to go any further. But let's go further, 350. So now you can start to see the charge. When I let go of the switch, you can see the slow action of the eye. Well, this capacitor is testing really good. Do we dare go higher? Why not? Well, okay. Well, surprise. So this capacitor, according to those tests, is a 0.04 instead of a 0.05, but is not leaking. If we look at the quality of the wax on it, it's still got. Oop, where are you going? Tripod collapse underway. If you can look at the end of it and see if the wax is still covering it, it's not. Can you see those little gaps in it there, right around here? I don't know. This is testing a little odd from what I'm used to. Oh, I just realized what it is. Okay, my mistake as usual. Okay, I have the answer. I have the answer. Let's go back to the tester here. I have the answer. Here's the capacitor. The answer is this switch was set in the wrong spot. Click. Now, so it was set for doing electrolytic capacitors, which are difficult to test this way anyway. And that's why it was behaving the way it was behaving. Now I've realized my error. I'll put this back to 50. Now we're going to get some results here that make some sense. Okay, this dial doesn't mean anything, by the way, while we're doing the test. This is for taking an actual measurement. This time what I expect is this thing's going to close and stay closed. No, it did open. 150. So it's not going to open on 150. Well, it's not terrible. This is not a terribly leaky capacitor. You know what we're going to do? We're going to measure its capacitance with this too. It's actually a fairly accurate device. I just want to make sure this thing is discharged completely. Probably is. So it's a 0.05. So on the capacitor scale, 0.05 is going to fall in this range here. Now what we do is watch the eye to see the eye open when I hit the right spot. See it right there? And we'll go down. Now a good capacitor, the eye opens right up. This is just barely doing the thing. Uh-oh, cats are coming back. So where is that? So that spot right there is just under 4 microfarads. It's exactly the same reading as the other device on this capacitor. So it's not quite 5. Well, Okay. Tested the heck out of that capacitor. Let's probably paid more attention to that one capacitor than most any other. Well, what do you think? I think he's looking for trouble again. Okay, I'll put a new capacitor in there and we'll turn on the radio. It'll be the last thing we do today. I'll put this guy in. We'll turn on the radio and see if the swooshy sound has disappeared. Okay, ready for another test. So volume is part way up. And wow, we're on the broadcast band. Here we go. Dim bulbs at first, just to be sure. Okay. Today's power is 108 volts, 109 volts. There we go. Let's listen to this carefully and try to identify any weirdness. Let me tune, make sure it's properly tuned. Two stations are really close together there. So I still hear the heterodyne or the swooshy tone.
3 more years before he passed that mark again. Bedard's on pace to pass his 61 last season. And he would be the first #1 pick since Austin Matthews to start his career with back-to-back 60-point seasons. So JD, that's the Bedard.
So what I'm listening to is the S's as he talks. You hear that sound, if it's there or not.
Pretty surprised to hear that that was Nathan McKinnon's start to his career, because I genuinely forgot like that happened. And like he played games too, like it wasn't major injuries.
Yeah, I'd say you can hear the S's. They're maybe not quite as pronounced as they could be, but look at the size of the speaker, for crying out loud. It's a gigantic thing. How is this big cone gonna move at 60 or 10 kilohertz? I don't know.
21-16 in goals, and that was through 82, 64, 72, 82 games.
There's no swooshiness just listening to it. I'll tune a little bit back and forth.
He's a guy that he's relating to a struggle.
So there is a tone in there. It's very hard to hear.
Perspective. Like if you're Connor Bedard, you're thrilled to get.
So I think what's happened is the strong radio signal has caused the automatic volume control to reduce the amplification of the front end of the radio, and consequently we're not hearing these interferences as much. Basically the radio is in a sense being overwhelmed by the strong signal. That's really not the right way to look at it though. It's not being overwhelmed. It's just its amplification factor is being reduced a lot. So let's try a shortwave band here. We'll try the oh, that's not how you do it, Jim. This is how you do it. So this is the 6 to 18 megahertz band. This is the everything band.
Aburrimiento. Esta necesidad de estimulación nos impulsa a buscar actividades más gratificantes o buscar un cambio en nuestro entorno. El aburrimiento y la motivación están estrechamente relacionados. Cuando nos sentimos aburridos, nuestra motivación tiende a disminuir.
So that's probably Radio Marti, which is an American broadcast on shortwave aimed at Cuba, to provide Cuba with the American truth. Oh, there's a bunch of stations here. They're fading in and out, so that's the same one. And this is kind of demonstrating the problem with a band that goes all the way from 6 megahertz to 18 megahertz. A tiny little motion, it makes a big tuning difference. And that's why the spread bands are so much better. Let's try them. Okay, next band. This would be the, this was 9, wasn't it? 9, 11, and 15. This is 9. Could be there's nothing there to hear. A little too quiet for me. Okay, I'll try the next band. The hiss got even quieter here. Nothing at all. Oh, what was that? Something fading in and out. It's out. I think that's it. It's just nothing. It's maybe some utility broadcast or something. I don't know. I don't know if... Oh, maybe it's some dirt in the tuning. Okay, nothing there. What's that? When I listen to noises like that, and I think we all have the same thing, my powerful imagination can make me think I'm hearing voices. I'm hearing voices. This is much louder. This is a much louder band than the last two. I was going to say it's kind of unsteady. Yeah, it is. Not that. It's got to be this. Yeah, maybe this switch is wonky too. Tune, man, let's tune. This seems to be picking up stuff. It's just noises, but no stations. Unfortunately, these old radios, their tuning range is whatever it was back in the day, and then sometime after these radios were made, the bands were expanded because they were so crowded, so they became bigger. But the radios didn't become bigger. You know, this didn't change, so it still captures a smaller part of the broadcast band, and there's stations out here on the fringes this thing cannot pick up. That's part of the problem here, but wow, that's too quiet. So, oh, what just happened there? Whatever it was, it went away. What happened there? Ooh. Sounds like a component failing is what it sounds like to me. The rush is going up and down, but that's no guarantee at all. Okay, well, we've still got lots of... that's not doing anything. Lots of parts here. Very good. That is it for today here. So, thanks a lot for watching. Tomorrow, we'll just continue to slowly change out these capacitors, checking the radio each time to see what the influence or effect was. And I'm quite reassured that this is going to be a nice radio when it's done. It's going to receive well. That's what I think. So, thanks a lot for watching. I very much appreciate it, and enjoy your day. I'm going to try to enjoy mine. See you.